Example number 2. So let's go through our steps. The first step, distribute to eliminate parentheses. We obviously have parentheses, so we're going to distribute the -3, and that gives us negative 6f minus 12 equals 2f plus 12. So that is the first step. Second step, combine like terms on each side independently. We don't have like terms on the left side or on the right side, so we can skip this step. The next step says move variables to one side using inverse operations. So we have a -6 and a +2. Again, I always like to move the smaller of the variables to the other side. You don't necessarily have to do it that way, but the -6 is smaller than the +2f. So the inverse operation of a -6f is a +6f. I'm going to add that to both sides. So we're left with -12 on the left side. On the right side, we have 8f plus 12. So we've accomplished that step. We've moved variables to one side. And then finally, move constants to the other side. And remember, we want to move them to the other side away from the variable. So this time, this +12, it's got to go because we want the f isolated. So we're going to subtract 12 from both sides. 12 minus 12 is 0. -12 minus 12 is -24. And then finally, multiply or divide away the coefficient. So this is 8 multiplied by f. So we're going to undo this multiplication by dividing both sides by 8. And we're left with 1f equals -3 as our answer. So number 3's got a lot going on. But first off, we're just going to follow the steps. We want to eliminate the parentheses first. So I'm going to rewrite everything in the problem just below. 4m plus 7 minus 3m. And when I distribute the 2, I get 2m plus 6 minus m plus 1. So the only thing that changed in that first step was distributing that 2. The next step is we're going to add like terms independently on each side. So this left side, I have a positive 4m. And be careful here, a -3m. So positive 4 and -3, 4 minus 3 gives us 1m. And then the plus 7, I'm just going to bring down since it doesn't have a like term. Do my vertical line down the middle. And then let's look at the right side independently. The right side has some like terms. It has a positive 2m and a -1m. So 2m minus 1m is just 1m. And then positive 6 and positive 1, add those together, we get positive 7. Probably see where we're going with an answer in this problem. But the next step is we get the variables together. There's not a smaller variable. They're exactly the same. So when I subtract m from both sides, these m's cancel and these m's cancel. And then we're left with 7 equals 7. That is a true statement. And all that means is true's not the answer. The answer is infinite solutions. Meaning no matter what we substitute back in for x in the original problem, it would make this equation true. So infinite solutions is our answer because this last statement is true. All right, and then our final problem, we've got parentheses, so let's distribute the 4. We get 12p plus 20. On the other side, we're going to distribute the 3, and that's 30 plus 12p. There are no like terms on the left side or right side independently. So our next step is we're going to get the variables together that are on opposite sides. Well, both of them are positive 12. So it doesn't matter which one we decide to move, because if we subtract 12p from both sides, those cancel and those cancel. Again, I don't know why it's all deleting, but that's fine, because they're ultimately, they all cancel out, and we end up with positive 20 equals positive 30. And that does not make sense. That's false, which means there is no solution. There's no value we could substitute in for p in this problem that makes this equation true. And again, that's because the variables canceled out and we were left with a false statement. That's how we know.